Welcome back to our next science video. And today we're going to continue looking at materials and their properties. Um, and the aim of today is to look at whether or not we can investigate what water absorbency is and what materials might be good at it. Quickly, what we need to know to do this is we need to know what absorbency means. What does the term absorbency mean? And what can we do in order to investigate that? We need to be able to make predictions based on knowledge that we already have. In order for a science prediction to be valid, you need to have thought about it in terms of what you already know about science. If otherwise, it's a guess. So it should be using knowledge that you already have, or at least an idea that you already have. And then we need to investigate materials to find out how absorbent they are. And we're going to think about how we might follow a set investigation in order to get to our answer. So, a recap. We looked at the properties that might make a good umbrella. So, what sort of properties do we think would? This is a recap from our last lesson. So, have a think, pause now, and see what you think. Okay, so there's a few that stand out. We had one that might be needed, might not be needed. The ones that stood out is that it needs to be water resistant or non-porous. Otherwise, what's the point in having an umbrella? Just put my umbrella up and let the water still fall on me. It makes no sense whatsoever. So being water resistant is highly important. The next one's flexible. When you think about how an umbrella works, it sits on top of a frame and is stretched out across this frame in order to make the shape of the umbrella. If it wasn't flexible and it was very rigid, then we wouldn't be able to do that. And also, we wouldn't be able to put an umbrella up and down, so you'd have to carry around an open umbrella the entire time as well. And lastly, strong. And the reason why it needs to be strong, or at least resistant, is that at times you get very heavy rain or very high winds. And if you're trying to stay dry in those circumstances, what you don't want is for the material to become damaged, a hole to form, because as soon as you get a hole through your material, you're going to get wet again. And what's the point of an umbrella? To try and keep us as dry as possible. So they're the properties we had for an umbrella. So if a material doesn't or does not let the liquid in or through and keeps it out, it's called water resistant or non-porous. But what if it does let a liquid in? In fact, what if the liquid soaks right into the material? What do we call those types of material? And you've all done this. So imagine this scenario, you have your drink on the side and you accidentally knock it over and water goes everywhere. What do you do? What do you get in order to tidy that mess up? Well, you have to think about a material that's going to absorb that water, it's going to take it away, it's going to absorb the material up. And that's what we mean by absorbent. An absorbent material absorbs water or lets water in. If you think about using a water resistant material to try and dry that water up, all you're going to do is push it around the table and probably onto the floor, at which point the floor, if carpet, is probably going to be absorbent and then will soak up all of the water into it. So we do need to think about what materials we might reach for and have a think. What ones would you go for in the terms of knocking over a cup? What would you look for? What material would you get? So today's problem is we're going to have to think about what material is the most absorbent, or what material is going to do that job the best. We can go and get in order to tidy up that mess that we made by knocking over our water. And what we're going to do is I've written the investigation up with a few gaps in, and you're going to follow it. Add in the details as you go along, and then you're going to try it and take a picture and make your own results. And we're going to do it this way so that you know the process of writing, going through how we do a investigation. You know the importance of a method and why a method is important for other people to carry out the same investigation you have. And how you go about setting up your results table and your conclusion. So the first thing we need is our question, our aim. And we say, so in this case, our question, our aim is from my sample, which material absorbs the most water? Quick question. Why do we use the term from my sample? Have a think. Why do you think? Maybe test your parents out. Why do they think? Well, the reason we say from my sample is that we don't necessarily have access to every single material that we could use to test. And this is quite commonly the case. We're only actually testing a sample set of materials. Now, it might be a sample set that we think actually are absorbent. We're just seeing which one's best. It might be a sample set of what we have, but it's still only a sample. It's not the full range of materials that we could test. And that's why we write it like that. Secondly, we're going to make a prediction. I think that whatever the material is will absorb the most water. I think this because. Now, a good prediction always states why you think your answer might be that. What prior scientific knowledge do you have, or prior information do you know that helps you inform that particular prediction? And that's an important step because that's the bit you're validating by your test and by your conclusion. Normally we have a diagram. Diagrams are massively important. They say that a picture is worth 1,000 words. And the reason for that is that you could describe this entirely and it would take you so long to do. You'd have to be quite specific in the way in which you're writing it. Or you can show a picture and people can get an idea from a picture much, much quicker than they can in any other way. So that's why we use a diagram. It just helps people understand exactly what you mean and what you want them to do. Then we write our method. And the method in this case is a step set of instructions, much like an instruction text that we might be writing. And we try and be as specific as we can in order to help the people do exactly what we've done. We can't miss a step out because if we missed a step out, then they wouldn't be able to fulfill the test in the right way. So let's have a look. Our method for this one is collect a selection of different materials. Just check first and don't damage anything that's important. Don't like cut a strip out of your top or something because that seems like a silly idea to do. First off, you'd be walking around with a strip of missing clothing, but also you would damage it. So think about what you're going to get. Make sure it's okay with your parents. Cut them all to the same size to make sure it's a fair test. In order for it to be the same, we have to test the same amount of material. Stick one end to a wooden spoon or something, a rod, a stick, that you're able to suspend them from. And suspend means to hold them up. And suspend them across 2 cups because that's easy to have. It's something you should have in your house. Something similar to that, 2 cups, whatever it happens to be, 2 boxes. So the ends of each material nearly touch the ground but don't quite. Then place a tray of water under the materials so that the ends of the materials dip into the water. You can place food colouring into it. I did it, it's just to make it so that it's easier to see, but you don't have to do it. But if you do have it, it does make it easier then to record your results. Leave for 5 minutes. Now, in order for this to be pretty accurate, you do need to measure exactly how long you've left them for. And then you measure how far up the material the water's climbed or has been absorbed. That's what we're thinking about. So here's another diagram just to show you what I mean. We've got 1, 2, 3, 4, 5 different materials. You can see they're taped to the top of a wooden spoon here and between 2 mugs, and they are dipped into this water down here. You can see is coloured orange, just so I can see how far up it's travelled. And then when we come to measure it, what we're measuring is the distance from the water to the top of where they go, from the water to the top of where they've absorbed, from the water to the top of where the water is, to the top of where the water is, to the top of where the water is. And that then is put into our table of results. We put whatever the materials are down here and how far up they've been absorbed. And whatever you're measuring in, so we're measuring in centimeters or millimeters, whatever you happen to be measuring would go here, and then you can just write the data in there. A last and final thing, just to finish off the test, is that you need to think about your conclusion. So your conclusion is, I found that whatever the material happened to be absorbed the most water. This shows that my prediction was correct or incorrect. And for bonus points, you could write why you think that may have been. Why does it absorb more than you think? Or what would be the point of that material absorbing lots of water? And then onto Tapestry, I want you to place a photo of your investigation, much like we've just done here, and your table of results to go alongside it so you can see that you carried out the investigation. So, one final thing to think of. Here's a scenario. Here's our scientist, and here's a sample selection of individuals, parents with children. So this one says, yay, my baby just did a number 1 and I'm still dry. Whereas this one says, my baby just did a number 1, but it's not so dry. And this one over here says, this one's dry, but I think its nappy is not comfortable. So what I want you to think about is what properties would make the best nappy for a baby? What do we have to consider? Much like our umbrella, we're thinking about it being water resistant and strong and flexible. What properties would we need for a nappy for it to be effective and useful in order for the baby to be happy? Have a think. I'll see you in the next video. Goodbye.